My name is Michael Kirby, and I'm a postdoctoral researcher at Northwestern University. I'm one of about 600 scientists working here at the D0 experiment at Fermilab. D0 is one of two experiments that's currently taking data at the Tevatron, which is the highest energy particle collider in the world. So at the Tevatron collider here at Fermilab, about 2 million times a second, we have a proton and an antiproton bunches that pass through each other, trying to create new forms of matter. And the problem is that we can't record every single one of those events. It would just be too much data to write to the computers that we have. And so what we have to do is we have to filter those events down. So we have to start with about 2 million events per second. Then we have to filter that down to 2,000 events per second using a system of online computers. And then from 2,000, we filter that down again to about 1,000 events. And then finally, we filter that using online computers that reduce it from 1,000 to 100 events per second that we then write to tape located remotely here at site. So what I'm working on right now, the search for the Higgs boson, it's one of the most exciting things that is going on right now in particle physics. It's a challenge that we've been addressing for about 40 years since Peter Higgs first theorized a Higgs boson to give mass to all of the particles of matter. And so what we have to do is we have to come and look at all of these events that we've recorded over the last 7 years and try and filter out all of those events to just the very select events that we think might contain a Higgs boson. And then if we analyze those events very, very carefully, we think we can separate the signal of a Higgs event from all of the other backgrounds that we see in all of the collisions that we've recorded. And then if we can do that separation, separate the signal from the background well enough, then we'll hopefully be able to say that we have discovered the Higgs boson and the mechanism that gives mass to all of particles